Hey guys, this is going to be my first attempt at trying to make a little program where you can see what I'm doing with my smartboard. So to quickly go over, in the last lessons that we had way back when, we looked at a sinusoidal graph, looking at that clock and looking at the height of the end of the second hand above the x-axis as it spins around the clock. And we looked at how that graph looked. And remember that it looks kind of like a wave going on and on and on. And so we call that periodic data, meaning that it repeats at regular intervals. And so this is still a part of that first lesson. This was a graph in there, and it shows a couple of key characteristics of a sinusoidal graph. So as we can see here, there's a couple different definitions. So this one here is our midline, our median value, or our median line, and that's essentially just the middle of the graph. And so what we'll see is that the graph will go the same amount above and below the median line, and we call that the amplitude. So that's the amount above and below. And again, the amplitude from the top to the midline and from the midline to the bottom will be an equal amount. So those are a couple things. We have the maximum value. So the maximum value is the highest point on the graph. And again, the maximum that's right here is going to be the same as the maximum that's here. It's going to be the same in just shifted forward. We also have a minimum value, so that's the lowest value here. Of course, my haunted smartboard. And we have the same minimum value. Oh my gosh. We have the same minimum value over here. And so those are a couple key parts. We also have the start point. So remember what we called the starting point. It's always on the up swoop of the line. So where it's going up, and it's always on the midline. So right now that starting point is right here, but it's also right here. That's a starting point as well. And the last one that we haven't really talked about is the period. So the period is the amount of time it takes for the cycle to repeat itself. So where it goes from one maximum to the next maximum. How they have it shown here is from one starting point to the next time that it reaches the starting point. But the period, again, we could also be looking, up here, it goes from one maximum to another maximum. So that's the same amount of time that it takes for the graph to repeat itself. So those were the things that we looked at in the first lesson. Now, if I can find it, the second lesson. Oh, is this what I have? Sorry. See, it's just as silly as when I do it in class. I still need sinusoidal 1. So a sinusoidal regression. So we're going to do a regression in the same way that we did regressions in the polynomial units. So you might need to look back at your notes. Again, I'll post all of those notes from the older ones. Sorry, I also have a 4-year-old here right now who's going to interrupt me quickly. So I'm just going to pause my recording and hang on. Sorry, I'm trying to get work done with a child is not the easiest. So we're going to do regressions the same way that we did in the last part again. So it says recall our clock and table that records the height of the tip of the second hand. So again, that's looking at the second hand. How high is it from the x-axis? So we figured when it is pointing straight up, it is the length of the hand is 10 centimeters. So it would be 10 centimeters plus 10 centimeters, which is 20 centimeters. And so that would be found at the 60, at the 0, at the 120. And then when it is pointing down, so when it is pointing straight down, again, it is going to be 0 from the x-axis. So we'd see that first at 60 seconds, then again at 90 seconds, and then again when it's pointing at either the 9 or the 3, representing 15 seconds and 45 seconds respectively, it will be in total 10 centimeters from the x-axis. So it says determine the regression equation using your calculator. So what you need to do is in your L1 and L2, in your stat part, you need to insert those into those two columns. So hopefully you're thinking, hey, I can pause this and do it really quickly. So putting it into L1 and L2. So a reminder for the people that are using TIs, you use stat, you press the stat button, then you press edit, and then you're entering the values into L1 and L2. And then once you have them all entered, you press stat, calculate, and I think you need to scroll way down to the one that says SIN. It says SINREG, but that's sinusoidal regression. So I think it's letter C on the list. So peek around for that. And so the regression equation using your calculator. So it will give you the full equation of what it actually looks like. And so I'm going to stop using the red pen since it's doing weird stuff. So the regression equation from those data points, what we get is 10 multiplied by the sine of 0.10472 x plus 1.5708 plus 10. So those might be rounded values. I don't have a calculator right in front of me to double check, but some of those might be rounded values. Sorry, I'm drinking a coffee. You can't see that. So that's our regression equation from the calculator. So this is kind of like when we would put it in polynomials and we would get our linear equation y equals mx plus b, or for our quadratic y equals ax squared plus bx plus c, or for our cubic ax cubed plus bx squared plus cx plus d for our cubic functions. This is what our equation actually looks like. So the next question says graph the curve below. Your calculator must be in radian mode. So I think I had you guys check before that it was, but again on the TI, it's up near the top. There's a button that says mode. Just press that. You'll probably have it highlighted as degree mode right now. So just highlight radian, press enter, and then it will be in radian mode. Casio, you might have to flit around to figure out where it is. Send me an email if you can't figure it out, and I can see if I can figure out how to get it into radian mode. So graphing the curve below, what you can do is you can now put in your y equals for that equation. So y equals, be careful with brackets here, 10 times, again, the sign. It'll open a bracket for you. So 0.10472 x plus 1.5708 plus 10. Just a minute. Sorry, had to deal with the child again. So putting it into Y1, and then you can graph it out. So thinking about what your window should look like based on that data set. So we see our X values. So that's the time column. Your X values go between 0 and 120. So you definitely want it to go at least that far along the bottom. So 0 here, 120 somewhere over here, and you can let it go out further. So we have data point at 60, data point at 30, data point at 90. And we see the y values, so that's the height of the second hand. They just go between 0 and 20. So you might put in 25 so that you can see beyond that. So you might put your y values between 0 and 25, or between -10 and 25, so you can see the whole graph. But once you graph it out, you'll see that it doesn't look like a straight line. Like it doesn't go like this. Instead, what it does is it has a little bit of a curve to it. So that's what's representative of a sinusoidal graph. So the other day when we were doing it as a little bit of an exploration, most of you guys actually drew it as a straight line, but that's not actually how the data is represented. It's curved line. I'm off by a little bit. But the curved line that would repeat. So it'll look something like that. So the next question, I believe, says, determine the maximum and minimums of the graph using your calculator. You can pretty easily figure it out using the data table, but again, to practice how to find out things in your calculator, again, you use your trace button and you'll be calculating your maximum and minimum. So the maximum, when you use your trace function, again, it's not always going to be as easy as just looking at the data table. So the maximum is reached at y equals 20. The minimum at y equals 0. And again, they're reached every 60 seconds. Offset, though. That's not what I wanted to write. So reached every 60 seconds. And the median line, you're going to have to give me a few minutes, buddy, okay? Okay, you need to give me 2 minutes, okay? So the next question is graph the median line in Y2. So the median line, again, is the middle. So the way that we could calculate out the median line, again, it's easy on this one based on our data points, but the median line is your distance halfway between your maximum and minimum. So again, our max was at 20, our minimum was at 0. So 20 plus 0 divided by 2 will give us our median line. That's halfway between. So our median line is the line y equals 10. So if we go back to the graph, our median line again would be, see if the red pen will do red penning. Oh, it does. So that's the line y equals 10. And again, that's our median line. Finding the amplitude. Oh, I guess I've done a little bit of this. So we learned in the last lesson, the amplitude can be found using the median value and the maximum and minimum. So amplitude is the max value, subtract the median value, or amplitude is the median value, subtract the minimum value. So we had to figure out what the median line was, but we did that in the previous question. So our amplitude, our max value is equal to 20. Our median value is equal to 10, so our amplitude is 10. It should be the same if we do it the other way, where we start with the median value and subtract the minimum value. So 10 subtract 0, and we'd get an amplitude equal to 10. So just putting that onto that graph that we had previous. So the amplitude, again, is a maximum value to your midline, or your midline to your minimum value. So again, that is 10 units. In this case, I guess it would be 10 centimeters. And that is our amplitude. And the last little bit of this one is the period of the graph. So the period is the time that it takes for the graph to repeat its pattern. So one way to find the period is to find the distance between two maximums or two minimums. We've already found a minimum and a maximum, so now we can find the next minimum or maximum. Since the period is the distance along the x-axis, we need to subtract the x-coordinates of our two minimum points or two maximum points. So our first minimum that we reach, if we're starting at time 0, I just saw Tracy. Hi, Tracy. Our first minimum was at x equals 30. Our second minimum is at x equals 90. So again, the minimum value was 0. So we reached it at 30 seconds and we reached it at 90 seconds. Or we could do it based on our maximum value. So our first maximum is at 60. So that's when the hand has gone all the way around one time. Our second maximum is at 120. So in both of these cases, if we look at the difference between our maximums or minimums, we get the period. So you see in both cases, so if we went 90, subtract 30, that's 60. If we went 120, subtract 60, that's 60 as well. So the period is equal to 60 seconds. And that should make sense, since we previously said the period is the amount of time it takes for it to repeat itself. So the next question says finding an unknown y value. So how high will the second hand be at 35 seconds? So if you look at a clock, or you can think of a clock, at 35 seconds, it's going to be pretty close to 0, but not exactly 0. And again, since the graph is not straight line from point to point, again, it has a curve to it. We can't just estimate or anything like that. So what you can do is you can use your calculator. And so in this case, it's an unknown y value. So we're saying that x is equal to 35. So what does y equal? And so we know in our calculators, there's a couple different ways that we can look at this, but the easiest is you're going to trace, and I think it's number 2, if I'm not mistaken. It's the one that says value. Number 2 might be zeros. I wish I had brought my calculator. Oh no, it's number 1. I wrote it in my notes. Trace number 1. If you're using a TI, sorry, Jax. Trace number 1, or that second calculate number 1, I guess is what it should be. When x is equal to 35, and then you press enter, and you will get y is equal to 1.34 centimeters. I guess we should have units on it. And finally, the last question of this lesson is finding an unknown x value. So this one's a little bit harder. So this is saying, well, not really that much harder. What is x equal to when y is equal to 15? So it says, at what time is the second hand 15 centimeters high? Hudson, can you be quiet? Just one more. I have one more question, buddy, and then we can go to the bathroom. So it says, if we're given a y value, remember what we can do is substitute into y2. Y2 is equal to 15, and then we can trace the intersection of the graph. But thinking about it, it's going to happen several times. So if this is our line, y2 equals 15, it's going to intersect several times. It's going to be at 15 centimeters, quite a few times in between. So tracing the intersect. So we're going to trace intersect. So again, that's second calculate, and then I don't remember what number intersect is, but there will be multiple points. So the first intersection, again, you want to scroll your little controller over close to the point of intersection. The first one will intersect at the coordinate 10, 15. So that's saying at 10 seconds, it will be 15 centimeters high. The next time that it will intersect, so the second intersect, will be at 50, 15. So thinking about a clock, at 10 seconds, it's going to be there. Same thing at 50 seconds. It's going to be at the same height. And then we'll have the repeat. So this doesn't respond to our period because it hasn't gone all the way around. So our third one should be 60 seconds after the first. And if you trace the third intersection, it's at 70, 15. So it's gone around one time, that's 60 seconds, and then it will go 10 more seconds to be the same as originally. So that's a 60-second difference between those because, again, the period of our data is 60 seconds. So that is that lesson. Thanks for coming to my TED Talk. Now try the questions on the next page of your workbook. Hudson, do you want to say hi? All right.